Zach draws this shape on a grid. Lauren starts to draw an identical shape on the grid below. Write the coordinates of the missing point. So the word identical tells us that the shape will be exactly the same size. So the point that's missing is this point here. To get to that from this point, we can go down 1 and then 3 squares to the right. So on this grid, we can go down 1 and then 3 squares to the right, and we know that our point will be here. Now to write coordinates, we always go down and look at the x coordinate first. So if we go down, we have 6, and then from the point, if we go across, we have 3. So the coordinates are 6, 3. Each shape stands for a number. Work out the value of each shape. So here we have a triangle and 2 circles, and that gives a total of 27, but we can't work out the value of the triangle or the circles from that because there are many possible solutions. Now we have a triangle, a circle and a star, and that gives a total of 30. But again, there are lots of possible different answers. So let's look this way. If we have 3 triangles, that gives a total of 45. And if we know that 3 triangles have a total of 45, we can work out the value of a triangle by dividing by 3. 45 divided by 3 is 15. So we know that the triangles stand for 15. So we can write 15 on our triangles. Now, if we look at this row, we have a triangle and 2 circles, and that gives a total of 27. So 15 plus 2 circles equals 27. If we subtract 15 from 27, that tells us that the 2 circles together must be 12, because 15 plus 12 is 27. And if we know that the 2 circles together are 12, then one circle will be 12 divided by 2, so 6. So we can write 6 on our circles, and then to find the value of the star, we have 15 plus 6 plus the star equals 30. 15 plus 6 is 21, and then if we subtract that from 30, we get 9. So the value of the star is 9, because 15 plus 6 plus 9 makes 30. So we have 15 for the triangle, 6 for the circle, and 9 for the star. Here is part of a number line. Write the number shown by the arrow. So the arrow is pointing right in the middle of -4 and -6, so that's -5. Here is a hexagon. Draw 2 straight lines across the hexagon to make 2 triangles and 2 quadrilaterals. So we know that a triangle is a shape with 3 sides, and a quadrilateral is a shape with 4 sides, because quad means 4. So we can draw a straight line here, and then a straight line here, and we have 2 triangles, one here and one here, and we also have 2 quadrilaterals, 2 shapes with 4 sides, one here and one here, though there are lots of different answers, different possible answers for this question. Ben thinks of a number. He adds half of the number to a quarter of the number. The result is 60. What was the number Ben first thought of? So he's added 1/2 and 1/4 of the number. 1/2 is the same as 2/4, so that means that he's got 3/4 of the number altogether. So 3/4 of Ben's number is 60, and we need to find the number. Now normally, to find a fraction of a number, we divide denominator times top. So divide by the denominator, then multiply by the numerator. But here, because it's a missing number problem, we need to do the opposite. So instead of dividing by the denominator, we can divide by the numerator, and 60 divided by 3 is 20, and then we can multiply that by the denominator to get 80. So Ben's number is 80, and we can check that it works because he had half of the number, and half of 80 is 40. 80 divided by 2 is 40. Then he had a quarter of the number, and 1/4 of 80 is 20, because 80 divided by 4 is 20. And then he added them together, and 40 plus 20 is 60, and that was his result. So that means that the number Ben first thought of must have been 80. Here is a number sequence. Write the missing number. We have 1, 3, 6, 10. The numbers are getting larger, so let's see if it's an addition sequence. 1 plus 2 is 3, 3 plus 3 is 6, and 6 plus 4 is 10. So we can see that the number that we're adding is increasing by 1 each time. We've added 2, then 3, then 4, so if we add 5, we get 15 as our missing number. All the children in Class 6 vote to pick a class captain. The choice is Holly or Dev or Joe. Dev gets 10% of the votes. Joe gets twice as many votes as Holly. What percentage of the votes does the winner get? So we know that Dev gets 10%, and then we have Holly, and Joe gets twice as many votes as Holly. So we can draw a bar twice as long. Now, percentages need to add up to 100. We have 10% for Dev, and that means Holly and Joe together must get 90%, because 10 plus 90 makes 100%. Now we know that Joe gets twice as many as Holly, so we can draw 2 bars the same size as Holly's bar. So these 3 bars together must be 90%. And if 3 bars are 90%, we can work out the value of each bar by dividing by 3. 90 divided by 3 is 30, so these bars here are all representing 30%. So Holly gets 30%, and then Joe gets 30 plus 30, so 60%. So the winner is Joe, and he gets 60%. And we can check that it works, because Joe gets twice as many votes as Holly, and 60 is twice 30. 30 times 2 is 60. 3 identical blocks are placed in a line 80 centimetres long. The gaps between the blocks are each 7 centimetres. Work out the length of each block. So the word identical tells us that all of the blocks are the same size. So first, let's work out how much of the 80 centimetres is taken up by the gaps. We have 2 gaps of 7 centimetres, and 7 times 2 is 14. So 14 centimetres is taken up by the gaps. So if we want the amount taken up by the 3 blocks, we can subtract 14 from 80, so from the total length. 80 minus 14 is 66. So that means the 3 blocks together take up 66 centimetres. And if 3 blocks take up 66, we can work out 1 block by dividing 66 by 3. And that gives us 22 centimetres as the length of each block. And we can check 22 plus 7 plus 22 plus 7 plus 22 is 80. place these numbers in order of size, starting with the smallest. So we have 0.19, 0.9, 0.091 and 0.109. So I've written the numbers out with the decimal points lined up, because if the decimal points are lined up, then our place values, so our ones, our tenths, our hundredths and our thousandths digits will be lined up as well. Now I find it easier to write zeros in empty squares so that all of our numbers that we're comparing have the same number of decimal places, so the same number of digits after the decimal point. And now we can compare these numbers in exactly the same way as if we had whole numbers, so starting with the largest place value, which here is our ones. Now all of our numbers have 0 ones, so we can move on to the tenths. This number has 1, this number has 9, this number 0, and this number 1. So the number with 0 in the tenths, 0.091, will be the smallest. And then one of our numbers with only 1/10 will be next smallest. To see which, we can move over to the hundredths. This number with 1/10 has 9 hundredths, but this number has 0 hundredths. So that means 0.109 is next smallest, and then we have 0.19. 0.9 is our largest number because it has 9/10, and all of our other numbers either have only 1/10 or 0/10. Here is part of a number line. Write in the number indicated by the arrow. So we have 8,000 and 9,000 labelled, but we need to know what each of these little lines represents. To get from 8,000 to 9,000, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So we can work out what each of these little lines represents by dividing 1,000 by 10. That's 1,000 because the difference between 8,000 and 9,000 is 1,000. 8,000 plus 1,000 is 9,000. And we're dividing by 10 because to get from 8,000 to 9,000 we have 10 jumps. So 1,000 divided by 10 is 100. So that means each of these little lines represents an increase of 100. So we have 8,000, 8,100, 8,200, and then if we keep on counting in hundreds, we'll get 8,900. Or rather than counting from 8,000, we can just spot that one jump or one line before 9,000 will be 100 less than 9,000, so that's 8,900.